So this is a question in which the charged particle is turning back because the kinetic energy that it has at the beginning as it is entering between the parallel plates is opposed by electric potential energy between the two plates. So in this case, we have an electron that is entering with an initial velocity of 6.56 times 10 to the power of 5 meters per second between two parallel plates with a difference of potential energy of 250, and the distance between the two is 5.80 times 10 to the power of negative 2. So the path that the particle is having on that case is it is going up to a certain point and then it is coming back to the original position. What we are looking now is the distance from the distance that it is traveling in between, the distance that it is traveling inside of the parallel plates. So this is what we are looking for. How far from the entrance point the particle is moving. Since the kinetic energy of the electron is opposed by electric potential energy of the parallel plates, because the natural flow of the negative charge is to go toward the positive, and since it is heading toward the negative, then the electric potential energy is pushing it, then the kinetic energy initial will be, or the object will be stopping at a point where there is no more kinetic energy, where kinetic energy is transformed based on the conservation law of energy into the electric potential energy where it stops. So this is the same as saying 1/2 mass of the electron initial of the electron to the power of 2 is equal to the change of voltage where it stops. And what we are saying on this case is, what is this delta V here? Why are we doing it between the negative charge and where it stops? Because the change of voltage is measured from the negative charge up to the point or a line that is parallel to the negative charge, and that will be the delta V, the change of electric potential energy times the charge of the electron. Now what do we have is 1/2 times 9.11 times 10 to the power of negative 31 times 6.56 times 10 to the power of 5. The whole thing to the power of 2 is equal to delta V stop times the charge of the electron is 1 elementary charge, 1.60 times 10 to the power of negative 19. From here, after we enter it in the calculator, we will find that the voltage, the difference of voltage in which the electron will stop is 122.5 volts. So what this is telling us, this number is telling us, is telling that the difference of voltage between the negative plate, again, and the line in which that is parallel to the negative plate, in which the particle stops, is 122.5. Now, based on the fact that the electric field strength between the parallel plates in magnitude is constant or uniform, and it is calculated as whatever is the change of voltage between the two plates over the distance between the two plates. And it is the same at any point. We can say that this is the same as delta V where it stops over delta D that stops. Okay, so now in our conditions, we have 250 volts, so that is the delta V total over the change, the difference between the two plates, so that is 5.80 times 10 to the power of negative 2 meters equals to 122.5 volts. So that is the distance of that, or the voltage that it is stopping over the distance that it stops. So from here, we find that the distance that stops is 100 cross multiply 2 that you know and divide by what is left times 5.80 times 10 to the power of negative 2 divide by 250. This will be 0.0284 meters, or you can say it's 2.84 times 10 to the power of negative 2 meters. So this is this distance here. I'll write it with a different color. So this is this distance here. Everything is happening from the negative plate. The distance that is traveling, the distance that particle is traveling will be whatever is the total distance between the parallel plates minus the distance that is stopping, which is the distance from the negative plate until it stops. So this will be 5.8 times 10 to the power of negative 2 meters minus 2.84 times 10 to the power of negative 2 meters to the power of negative 2 will be the distance that is traveling between the parallel plates is 2.96 times 10 to the power of negative 2 meters. So pay attention to what they are saying. Are they asking you for the distance that is traveling or the distance from the opposite plate? And this is what you have to keep in mind when you are working with something like this.